Hello, Advanced Algebra 2. Welcome to the Concept 38, Part 2 notes. We are going to continue graphing rational functions by looking at more complex functions and then also rewriting rational functions from one form to another. All right, let's start with this example. So all rational functions in the form y equals some value a times x plus a constant b over some value c times x plus a constant d also have graphs that are hyperbolas. We're going to graph them just a little differently. The vertical asymptote of this graph is the line where x equals negative d over c, because that's the value that will give you a denominator of 0. You can also just look at this equation at your denominator and say, what value will make my denominator 0? That's where my vertical asymptote is. The horizontal asymptote is the line y equals a over c. So a is the coefficient of the x in the numerator, and c is the coefficient of the x in the denominator. So now example 1, we have the function f of x equals 2x plus 1 over x minus 3. So let's start by locating that vertical asymptote. And remember, that's the value that's going to make the denominator 0. So hopefully you can see that in our equation, that would be positive 3. Now, using our little formula, we'd get the negative 3 over 1, which is 3. The horizontal asymptote will be those coefficients, so 2 divided by 1, or 2. And remember that that also defines our domain and range. So these are the values that x and y cannot equal. X cannot equal 3, and y cannot equal 2. All right, so in our table, let's go ahead and place our vertical asymptote and values around it and plug those into the equation. Remember, you can use the table function on your graphing calculator. And now go ahead and draw your graph. Start by sketching in the asymptotes. So where x is 3, that vertical line, and where y is 2. Now plot your points and you'll see those branches emerge. And we've got a hyperbola of this more complex rational function. Let's now try rewriting, okay? So we're going to rewrite g of x, which is in the ax plus b over cx plus d form, into our transformation form. So g of x equals a over x minus h plus k. Believe it or not, these forms do not have names, so I'm going to let you name these in your class. We are not going to graph the function. We will describe the transformation. Now, the way we're going to rewrite these is we're actually going to use long division. So this is saying take 3x plus 5 and divide it by x plus 1. Now, to start, you only look at the first terms. So in our divisor and our dividend. So our dividend is 3x plus 5, so we're looking at 3x, and our divisor is x plus 1. You say, what do I need to multiply the x by for it to become 3x, exactly the same? Well, I'm just going to multiply it by 3. And so I go ahead and distribute that 3 to both parts of the x plus 1. Now, just like normal long division, then I go ahead and subtract. So my 3x's subtract out, and I'm left with 2. That's my remainder. So I'm going to go ahead, and it's positive. So I'm going to add my remainder and put it over my divisor, x plus 1. There, now we have our equation in transformation form. So g of x equals, I'm just going to switch the order, 2 over x plus 1 plus 3. So right away we can see that we will have a stretch by 2 because our a value on top is 2. And we will shift to the left 1, I should say, and then 3 up. All right, let's try a few more of these. I've got a random graph on there, and we're not going to graph these. So let's start with number 5. Let's take x plus 3 and divide it by x minus 1. So we just multiply x by 1 to get it to be x. And so we distribute that 1 and then subtract. X minus x is 0. 3 minus a negative 1 is 4. So that our remainder is 4 over x minus 1. Now to write this in function form, f of x equals 4 over x minus 1 plus 1. All right, let's try another. So 2x plus 1 divided by 4x minus 2. It's a little tricky to think what you can multiply by, but if you take 4 times a half, you will get 2. So that would give you 2x minus 1. If we subtract, our 2x's subtract out, 1 minus a negative 1 is positive 2. So we'll get plus 2 over 4x minus 2. So our function is 2 over 4x minus 2 plus 1/2. And I'm going to write this as a 1/2 there. Now let's do number 7. Ooh, and I am dividing. Sorry. All right, so we have negative 3x plus 2 divided by negative x minus 1. So if you notice, just look at the first terms and multiply our divisor by 3. You'll get negative 3x minus 3. That first term subtracts out, and we'll end up getting a positive 5 for a remainder. So our function is 5 over negative x minus 1 plus 3. And that is how you rewrite. Now look at this real-life problem, okay? We are modeling now. A 3D printer builds up layers of materials to make three-dimensional models. Each deposited layer bonds the